Alaikum everyone, my name is Ali Suleiman, and today inshallah we'll presenting my assignment on manufacturing process, focusing on the slide from page 34 to 44. This material was taught by Dear Faisal Alayan, and I hope to explain each slide clearly and effectively. I will cover different shaping, processing and assembly techniques used in manufacturing, aiming to highlight the main ideas in a straightforward way. Let's start with the first slide. As we can see, first slide is begin. Let's begin looking at the main categories and shaping process. Here we will exploring a fourth type of method using shape material. Each one has a unique starting materials and techniques. The first process is called solidification process. This begins with a material in a heated liquid or semi-fluid state. The material is poured into a mold and as it cools, it solidifies, takes the shape of the mold. Examples include metal casting and blasting molding. And the second process we have called particulate process. Here the starting materials are powders, often metal or ceramics that we use in this process. The powders are compact and then heated to pound the particles, forming a solid shape. This process is often used in creating metal parts or ceramics parts. And the third one we have is the deformation process. In deformation process, we start with the ductile solid, usually metal, and apply a force to change its shape. Common examples are forging and extrusion, where the metal is reshaped by pressing or pulling it through a die. Material removing process is the last one, as we can see. In this process, we start with a solid piece of material and remove the excess parts to reach the desired shape. Techniques like this, like mechanic technique that we use, like drilling, milling, and turning, and the grinding of we use also grinding in this process. Okay, let us go to moving to the next slide. We have a solidification process, as we can see. This slide explains how heating transforms material into a liquid or plastic state, allowing them to solidify into a special shape. In solidification, the material is heated and until it becomes either fully liquid or very, very flexible. So we can pour it or inject it into the mold, as we can see. After we melt the metal, we inject it into the mold. As it cools, the material hardens into the shape of the mold. And also the common examples include metal casting. From metal products, most of the metal products are made by metal casting, and plastic molding also for plastic items. Let's move next slide. We are looking at the particle processing. This slide introduces how we use powders in manufacturing, particularly metal and ceramics, and the method to pound these powders into solid parts. As we can see here, we have a powder here down. The powders are compressed in a process known as pressing, As we can see, force applied from above and the bottom of the border. After compression, they are heated to fuse a particle together in a step called centering. This combination of pressing and centering helps create a solid piece with a desired shape. As we can see here, after we pressing the powder, we will get the desired shape that we want. It depends on the pressing and the shape of the tools that press the powder. And now let's discuss another slide. Deformation process. How we shaping materials by applying enough force to reshape them, focusing on techniques like forging and extrusion. Deformation process starts with ductile metals, as we say, that can be reshaped without breaking. The material is subjected to force that exceed its yield strength, allowing it to bend or stretch. As we can see, forging involves shaping the material by hammering or pressing, while extrusion push it through a shaped die to create long pieces. So the difference between them, we can see the material is pushed through a die. So this process called extrusion, and we have here is forging, because we use hammering or pressing. In this case, we use pressing, applied force above here, if we can see, and then we create the desired shape we want from this process. Let's go to the next slide. On this slide, we are exploring material removal process. As we can see, this section covers how removing extra material from a piece can help achieve a precise shape. Material removal process involve taking away unwanted material from a solid piece to reach a desired geometry. Machining process such as turning, drilling, and milling. Here we have turning, drilling, and milling are commonly used to remove excess material. Okay, let's move to the next slide. Now let's consider waste and shaping processes. This slide discusses methods to reduce waste, with a look at net shape and near net shape processes. These processes aim to use as much of the material as possible. In manufacturing, minimizing waste is the key to save resources and costs. Material removal processes tend to be more wasteful, as excess material is discarded to achieve the final shape. Means that the extra material that we have, we should take it and throw it, shape it, drill it, milling, doing anything to it to get the final shape. By constructing, casting, and molding, and particulate processing, waste is very little. There are two specific terms for low waste processes, as we discussed. We have net shape processes and near net shape processes. Net shape processes usually near all of the starting material and typically require no further machining. In net shape processes, we use nearly all the material that we have, all the starting material. And near net shape processes, this process need minimal attention work and produce only a small amount of waste. So in near net shape process, we need to make some machining to the part to reach the final surface of the final product that we need. And next we have a property enhancing process. Here I will explain how this process improves material properties like strength without changing the shape by heat treatment. But first, let us discuss what is property enhancing. A property enhancing process aim to improve the physical or mechanical properties of material without altering their shape, as we said, without changing the shape or the look of the material. How? By heat treatment. Heat treatment is a common example used from metal and glasses to enhance property like hardness, durability, and toughness. Sometimes this can lead to minor unintentional changes like warping in the heat treatment material. Let us move to the next slide. Here we have a surface processing operations. This slide covers a method like cleaning, surface treatment, and coating that change or improve the surface of a material. Cleaning remove contaminants like dirt or oil from the surface using a mechanical method. Surface treatment involve chemical modification or mechanical action like sandblasting to create a new layer or texture on the surface. And also we have coating and a thin film deposition to add a protective decorating layer on the surface, often for protective or aesthetic, means a protective layer that will protect the material from corrosion and to not expose it to oxygen or water. Let's move to the next slide. This slide focuses on changing that can happen to a material surface during processing, especially when using a mechanical energy. I will explain how this effect can sometimes lead to unintended results like residual stress or cracks. In many manufacturing processes, applying a mechanical energy is essential for reshaping or cutting. A common technique like forging or extrusion and machining often use this energy. However, this method can introduce residual stress and work hardening to the surface layer, and in some cases can cause cracks that weaken the material. This is the main idea of this slide, so let's go to the next one, slide 45. Now I will talk about the tolerance in manufacturing. This slide discusses how accurate manufacturing process can be and the impact and produce cost and waste. Tolerance is a degree of accuracy needed in a product dimension which can vary based on the process. Manufacturing processes tend to be very accurate, often achieving tolerance without plus minus 0.05 millimeter. However, achieving this precision can increase cost, and the tools that we use must be very expensive tools and very accurate. As we know, expensive tool equal to very accurate tool. A process like sand casting are less precise but create less waste. Balancing cost with accuracy based on the requirement of the factory or the place that we work on. Let's move to the next slide. The last one, I think. Yes, this is the last slide we have to discuss. Finally, we reach the final slide. We have assembly operations. This slide breaks down the two main methods of putting parts together in manufacturing: joining, which is permanent, and mechanical assembly, which is temporary. So if we want to join two parts permanently, we will use joining process. Joining process creates a permanent bond between parts. Examples include welding, brazing, and adhesive bonding. Adhesive bonding sometimes can be sometimes can be permanent or temporary. It depends on the adhesive that we will use. Where the joint part cannot easily be separated, as we said, because this will be like a permanent joining process. And also in the assembly process, we have mechanical assembly. Use removable fasteners such as screw, bolts, and nuts. This allows parts to be assembled and disassembled as needed. And here we reach the end of the assignment. This is the last slide, and I hope that my explanation was clear. Thank you for listening. Have a great day.